Water has been used to fight fires for thousands of years. Usually, water is readily available, and it has great heat-absorbing capability. But a Class B fire involving flammable or combustible liquids usually demands more than water for extinguishment. Although a hose spray may extinguish a small Class B fire, water is usually ineffective because it sinks to the bottom of a hydrocarbon fuel, often does not cool the fuel below its flash point, and may also spread the burning liquid. To solve this problem, fire protection professionals developed firefighting foam. In a flammable liquid fire, it is the vapors that burn, not the liquid fuel. This concept is important for understanding how foam works. Foam is simply made. Start with water and add a measured percentage of foam concentrate. Air is then mixed with this foam solution in a turbulence chamber, expanding its volume. The result? Bubbles, which float across the surface, extinguishing a flammable liquid fire because it suppresses the formation of vapor, separates the flame from the fuel, cools and smothers the fire by excluding oxygen. Foam also can prevent ignition at flammable or combustible liquid spills. Foam must be used correctly to be effective. The foam should spread relatively quickly across the fuel and form a tough, cohesive blanket over the whole surface. If crude oil is very hot or boiling, foam application may lead to a slop over, endangering nearby personnel and equipment. Foam is more conductive than water and must not be applied to Class C fires in energized electrical equipment. Foam can be broken down by hose streams, which should not be played into the foam blanket. Foam is also broken down by incompatible firefighting chemicals, chemicals in the fuel, or contaminated water. Standard Class B foams can also be broken down by polar solvents, such as alcohol, acetone, or ethanol, which are water-soluble flammable liquids. Since 94% or more of foam is water, it dissolves into polar solvent, making the foam ineffective.